Good morning students. Today we are continuing with the lecture Congestion Control in TCP. How congestion control is managed in the TCP protocol, right? In TCP protocol we talk about in the TCP header that window size will be sent and the when we transmit the data, right? So that is the window size to tell the sender that particular receiver can manage that much of traffic or handle that much of data in this system, right? Here you see we are seeing the RWND, that is the receiver window. CWND is the congestion window. Now what is the congestion window? We also have to take care about the network, how much the capacity of network for delivering of data. Maybe network will not deliver the data as fast as created by the sender. We also done that in the last slide. Maybe processing rate is high but sending the data to the network will be slow. In that case, actual window size will be determined, which will be the minimum from RWND and CWND, so that our data will not lost in the network, right? Now what is the congestion policy followed by the TCP? We start with the slow start phase, right? Increase the rate till reach a threshold. What is the threshold value? That is the value here we talking about the congestion. That is the value. After that value there may be a congestion in the network. So your sending capacity, your sending rate will, when sending rate will reach to the threshold value, after that data rate is reduced so that congestion will be avoided. What is the second phase? Congestion avoidance phase, right? If congestion is detected, then which phase will run? Slow start phase or congestion avoidance. It depends ki which phase we have to work. Policy in TCP: exponential increase, right? In case of exponential increase, you see we start, I will show you in the diagram directly. We have taken the window size as a CWND. In this example, CWND is taken as a one maximum segment size. That means we will send the one segment at a time, right? After the receiving of the acknowledgement, CWND will be increased exponentially. We have already assumed in this example that CWND is lesser than the RWND. What we have assumed? CWND is lesser than RWND, right? One thing, this is assumed. Second thing is assumed that after each segment we will get the acknowledgement. That is also assumed in this example to show you the slow start phase, right? CWND 2 to the power 0 1, one segment size जाएगा. Acknowledgement आया. As soon as we receive the acknowledgement, window size will be exponentially increase. Then one segment, अब कितना हो गया? 2 हो गया, right? In that case, one segment goes, one acknowledgement. Second segment goes, second acknowledgement. As we receive the second acknowledgement, After that, window size will be again increased exponentially. It is 4. Now you see 4 packets, 4 segments. First segment, first acknowledgement. Second segment, second acknowledgement. Third segment, third acknowledgement. Fourth segment, fourth acknowledgement. Now window size will be 8. Now window will be increased when 8 segments will be transmitted, right? As soon as we are sending the data, there will be a threshold value. I already discussed the threshold value. What is the threshold value? Threshold value is the value in which your after that maybe date congestion may occur, right? So in that case, what is the value? 65,535, right? 65,535, right? So how we determine this value? This value is determined by the window size. We have already discussed in the TCP and all. That is our window size, that is our threshold value. After the slow start phase, congestion avoidance phase will occur when window size value will be reached to the threshold value. Additive increase. What is the slow start algorithm? Exponential increase. In additive increase, there is a small difference. In case of additive increase, starting is the 1, we will increment 1 by 1. Other things are same here. One segment goes, one acknowledgement, then plus 1, 2. After that, 2 segment goes and 2 acknowledgement, then again plus 1. That's why it is called the additive increase, right? After that is the congestion detection phase. If congestion is detected, in that case multiplicative decrement phase will run, right? ध्यान से देखिएगा बच्चे से. Multiplicative decrement phase. In case of multiplicative decrement, there will be 2 cases when sender will see there is a problem in the network. First, sender start retransmission due to timeout, then sender will know implicitly that congestion is in the network. So what to do for the to remove the congestion? What it has done? Whatever the threshold value at that time, whatever the threshold value, right? It will be 1/2 of the current window size. किसका? विंडो साइज अगर मेरा 10 है तो 10 मिनट की ये क्या हो जाएगा? थ्रेशोल्ड वैल्यू को 5 कर देगा, फॉर एग्जाम्पल, राइट? इट सेट द congestion window size to 1 segment. It will start with 1 segment and it will start the slow start phase again. That means कि exponential increase will run. But when it receives 3 duplicate acknowledgement, what happens in this case? In case of 3 duplicate acknowledgement, it will set the threshold value 1/2 of the current window size. That step is same. Second, CWND उसमें 1 हुआ था. In case of duplicate acknowledgement, it will be the value of threshold, right? स्टेप बाय स्टेप चल रहे हैं बच्चे. पहले हमने थ्रेशोल्ड को कम किया, देन CWND को कम किया, and starts the congestion avoidance phase. Retransmission में slow start phase, In case of congestion avoidance, in case of duplicate acknowledgement, congestion avoidance. You can understand this thing with the help of diagram also. There are 3 cases in the slow start phase. One, slow start phase is running. One is the timeout. Second one is the 3AC case. First one is the timeout. Second one is the 3AC case. Third one is the congestion window size is greater than equals to threshold case. These 3 cases when we run the slow start. I already told you we start with the slow start, right? So these are the 3 cases, right? In this case, congestion may occur, it is not necessary congestion will occur, may occur. That's why it will run the congestion avoidance phase, that is the additive increase, right? Before running the additive increase, it will set the threshold value half of the window, and CWND is the congestion window size is current threshold value, right? After that, what is done? Congestion avoidance phase will run. In congestion avoidance, we have the 2 cases. How congestion avoidance phase will see? There is a problem in the network or congestion in the network. One is the timeout, second is the 3AC case. Timeout हो गया, then again move to the slow start phase. If receive the 3AC case, then congestion avoidance phase will be run. How it will be run? Threshold is half of window and congestion window size is threshold, right? That we will see with the help of example also. This is an example for that. Here threshold is 16, right? When it reaches to the 20, I show you. Our threshold is set to 16 segment, right? When it reaches to the threshold, then what happen? Congestion avoidance phase start, right? And that is additive increase. When it reaches to the 20, timeout occurs, right? As soon as timeout occurs, it will set the threshold value to 10, right? At that time, slow start phase will run again. You seen in this. When timeout occurs, then CWND size of one segment, it starts the slow phase again, slow phase again. So here you see start slow phase again, right? When it reaches to 12, there is a 3 duplicate AC case. In that case, we have the multiplicative decrease, right, phase. After that, avoidance additive increase phase will run. It is 1 plus 1 plus 1 S, right? So that I hope you understand well with the help of this example also, right? If you have any problem, then write in the comment box. Thank you, students.